Okay, welcome back. Uh, Full disclosure, I didn't realize the free version of the software I'm using had a 10-minute limit, so I didn't plan on making two videos, but here we are. Let's do the next example now. So we are still doing the non-integral solutions. This is the x squared equals negative 6x minus 6. Now, the way that I typed this in was I did x squared plus 6x plus 6. If you decide to do negative x squared minus 6x minus 6, in other words, if you decide to subtract x squared from both sides, you will ultimately get the same answer, but your graph will look different than mine. It'll be the same graph, but it'll flip upside down. That's okay. It's still going to cross the same point, so it's all right. So this is a picture of x squared plus 6x plus 6 for what we are going to be looking at here. Now, again, check the table. Sure enough, we can't see 0, but just as before, I can see y is positive 1, y is negative 2. So my first 0 occurs between negative 5 and negative 4. So I second calc 0, left bound negative 5, right bound negative 4. Guess doesn't matter. Press enter, and I will eventually get the decimal approximation there. And then you do the same thing for the other side between negative 2, where y is negative 2, and negative 1, positive 1. So it's between negative 2 and negative 1. That'll then get me the decimal approximation for that side. So pause the video, take a moment, and figure out the exact, not the exact, the decimal approximations for these two, and we can compare answers. Okay, so hopefully after you guys check that in the calculator, you guys got x equals approximately negative 4.7 and x equals negative 1.3 is what you should have gotten for both of those. So check answers with each other. I know I'm not there to help, but you guys have the steps written in front of you. We'll talk about a better spot to find the steps written out for you if this isn't really working too well, and we can always touch base more on it later. But hopefully this is good enough to get us moving in the right direction. Now, after we've done that, we've only got a couple things left. The first is, in some cases, I won't ask for the specifics. I just need to know what numbers it's between. So if I give you a table and it says determine the location of the zeros of the quadratic function, I'm really just doing what we were just talking about. I'm trying to figure out between what two numbers the x-intercept is. So I'm looking at the y values and I'll see, okay, here at x equals negative 2, y is positive 7, but at x equals negative 1, y is negative 2. So between negative 2 and negative 1, I have a 0. Similarly, at x equals 2, I have a negative 5, and x equals 3, I have a positive 2. So between positive 2 and positive 3, I have another 0. And that's genuinely all I need to know. Your answer would just be x is between negative 2 and negative 1, and then x is between positive 2 and positive 3. And that's it. These problems, they show up on the quiz. There might be some in the homework. I cannot remember, but this is all it's looking for. It just needs to tell me between what two numbers is the 0. You don't actually have to find the decimal approximation. Literally just tell me where it's located. Determine the location. And side note, if you're an English major, such as me, I'm sorry that my B is capitalized here and it's not capitalized there. I made this thing quickly. I promise it's not because I don't love you. Last thing, word problems. You'll see these all the times whenever we're doing quadratics, throwing some ball or rock or something in the air and seeing how long it takes to hit the ground. That's a really common problem. What makes it different between Algebra 1 and Algebra 2 is I use more scientific notation, which is to say scientific lettering. So H0 or H0 is the initial height. So if I'm standing on a cliff that's 1,200 feet in the air, that is my initial height. So I type negative 16t squared plus 1,200 into the calculator, and that's my graph. Now, sometimes you'll have to play around with the zooming, but usually it'll still show up in that regular negative 10 to 10. If not, you can adjust the window, and we can talk more about that when we see each other. But you'll see here at the bottom of your notes, left bound question mark, type the number in left to where the x crosses. Right bound question mark, type in the number to the right of where the crosses the x-axis. So it's got the instructions here. So if what I was explaining earlier wasn't quite making sense, realize at this bottom part of your notes, you do have some typed up instructions for you to try and follow to help figure out where some of this stuff is located. So that's all there is to it, guys. Just to recap, what we're doing here is we are just trying to look at a graph and determine where does the parabola cross the x-axis. Sometimes it's as simple as looking at the table to be sure, yep, it's right at 4 and 16 or whatever. Sometimes we use that second calc to get a nice decimal approximation. Other times, I just need to know what two numbers it's between. And that's really what we're looking for here. So, the video is available online. The sub who you're probably watching this with can get you access to the link if you need to watch any parts of it again, or you can rewind it. Otherwise, you guys are free to take on the worksheet, and we'll talk about it more when I get back to seeing you guys again. Thanks again.